Oh, what's up, everybody? Welcome back. Today we're working on our barcode scanner. Today's topic, we are trying to get reliable edge data out of something that looks like this, right? Because we're thinking if we get reliable edge data, then we can use that to like parse the code. Wow, crazy. So we're gonna look at I want to look at Hough transforms today, which we've briefly talked about in the past, but haven't really like implemented. So just for some background, this is what we're kind of working on, right? You get some image, we want to like extract the barcode kind of like aligned to the axis kind of from that image. So we do like some edge detection on like a low res version of this thing. We like downsample that even further and use that to kind of say like, hey, can we like find areas that have like gradients that line up, right? I guess this edge detection here, I lied. This is not edge detection, this is gradient calculation. So we kind of say like, for each pixel, how much does it change relative to the guys around it? And like, what direction does that change in? And that lets us like kind of cluster points according to, if their directions line up. And that lets us kind of like extract a unrotated barcode from this thing, right? We've tried a few things here. We had some ideas about like, well, we know that these edges are going to be like perfectly vertical if we could do good extraction, and maybe we can leverage that information some way. Everyone on YouTube is like, why the fuck don't you just look at like one pixel strip in the middle of the thing? And I think that that's just not really as reliable. I think that some barcodes are kind of like not perfect. We have like an example here of like just like the first photo I took in my kitchen. And like, there's a lot of things you might notice here. There's like a little bit of shadows here, which I mean, obviously like this is still parsable, but I'm not really like convinced that every single pixel here in like the light stuff is lighter than every single pixel in the dark stuff. At least there isn't like a really obvious bisection point. You'll notice that like in here, right, the darks are really like not as dark as you would expect, because partially probably from like the actual box being printed this way, and partially because of like, you can see that there's like pretty aggressive like noise suppression going on from the sensor. So, just looking at this, I think that you can get better signal if you leverage the information that you have like a big bar here, right? Like me as a human, I'm looking at this and going like, okay, I'm seeing like a strong edge here. And so I just think that like, if we do edge detection and like if we find like reliable lines for each of these guys, kind of like where like the start and end of each of these chunks are, I think that that'll give us like a more robust scanner. And I want to try it. Okay, I just want to try it. So other things that we've kind of encountered in the past, some of these barcodes, they do things like they get a little cute with it and they like cut out chunks of it. Sometimes the barcodes are like a little bit warped because they're on like a bag or on a curved surface. Sometimes if we try to just do like basic edge detection, there are going to be like holes that we have to deal with. So I think the plan here is to do some form of like edge detection and use the edges that we find as a way to fit lines, right? So that way, if we have like a chunk of stuff like this, right, and are like and if we like detect points on the edge like this, but we miss a couple, if we like fit a line through this, then we'll have like pretty reliable signal, I think. I think with that we can do a pretty good job. So basically, I think that we should try this thing called Hough transform. I'm saying that because that's the word I heard when everybody in YouTube was like, you should fucking use Hough transforms. I kind of agree. I've looked this up so many times. It took me a while to get it. But the basic idea here is you have points, right? So say I'm in like this picture, I've got like a line like this. At each pixel position, let's use a bit better call here. At each pixel position, including all the ones that are like this, you go like, hey, is there like a black pixel here? If so, then let's pretend that like, we'll say that like every single line that could go through this point is like a possible answer. What the fuck did I just click? Right, so like for here we go boom, 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 boom. Over here we go boom, 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 boom. Right, just every single fucking line. And what will end up happening is if you like count how many times every single line showed up, like the one that is diagonal is the only one that'll show up like a fuck ton of times, you know? So when I like skim the Wikipedia page, they basically say like build like a 2D histogram of this thing, right? Where you have angle as one axis and like offset, perpendicular offset from the center of that as like another option, right? So like, you know, they're kind of saying like, you know, this line, infinite line, can be described as a line that kind of is perpendicular. Like his location can be defined as this distance, and then his angle determines which way he's pointing. This is like not really what we want, right? I think that we can do a little bit better than this. We can probably also determine, or sorry, we can kind of like leverage information that on a barcode, all of your things should be like approximately aligned. So I think that we can maybe build like angle consensus first, and then build like offset consensus just as like horizontal offset or something like that. We'll see. We'll see. But the first step here is we have to make like edge detection that doesn't fucking like blow. So we have done like horizontal edge detection here before. I think we just need to make sure that we're like finding some parameters that don't like super suck, right? And then like, because this is kind of noisy, you know? So probably we need to do like a little bit of blurring before we do edge detection, and then find parameters that are like give us clean lines, but maybe with a couple holes in them, because holes will be filled, you know, we're okay with a few holes, you know? Yeah, so let's start there. Let's start there. So the way this like edge detection works for us for now is we've kind of like taken inspiration from the canny edge detector. I guess we kind of started this around like here. So this guy basically says like, yo, blur this shit. I think we're not doing this right now. Then they're like, calculate gradients, where all we basically do is we go like pixel by pixel, and we go like, at this pixel, we say like, hey, check on your left and check on your right, and if like stuff on right is bigger than stuff on left, you go that way, and if stuff on left is bigger than stuff on right, you go this way, right? And then you kind of like say by how much, right? You multiply the difference between those two. And then you do the same thing vertically. You end up with like two vectors, right? Boom, boom. And like this kind of gives you like, you know, a nice little angled line. Boop, right? With a little triangle. So we can do that. We can kind of do, and then what they say to do here is, if I am if my gradient is of a higher magnitude than the ones around me, like pick me and not them, right? And then they do other stuff that we're just kind of like not really doing, because we don't really care about this stuff right now. Also, on our situation, we don't need to do this like vertical gradient detection because we know that all the edges we care about are horizontal. So we're basically doing like gradient and then look for pixels, look for areas where the gradient is higher than the pixels around him. And so I presume that like a little bit of blur will make this a little bit better, right? Because right now it's kind of noisy, right? If you have gradients that go like whoop, 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 you're gonna say that both of these are edges, which we probably don't want. So we need to like make sure that like we get like one smooth peak. And then we also need to make sure that our thresholds for like what we consider an edge and what we don't are set correctly. That's kind of the two pieces here, I think. So let's take a look at this. Let's take a look. So before we've had success in doing like a vertical blur, right? We know that because all of our edges are mostly horizontal, like we can blur vertically without losing too much like precision on our edges. And I think that we had some pretty good success with this in the past. So can we just bring that guy back? Which I think that we removed from the GUI. Make GUI root. Here we go. Here we go. So let's bring that guy back. Let's do like, okay. We want the edge stuff there still. And then we probably want something that's like, oh, here. Blur. Perfect. Blurry. All right. What are we looking at? Okay, so yeah, here's what we extract. We blur it a little bit. And then get some gradients, and then can we fucking... I didn't want to do this anymore either, I don't think. I assume. Let's just kind of look at our edge detection. Okay, X edges. These guys just need to come from... Okay. Here we go. Here's our edge detection stuff. So we say... Oh, I don't want this shit either. Get this shit out of here. This is all failed experiments from yesterday. Ignore all this. Okay, edges. You store GUIs? Thanks for the prime. Much appreciated. So, what are we doing here? We look at the pixel on the left, we look at the pixel on the right after doing gradient. We calculate the gradient, we look at the gradient on the left, gradient on the right, and we say if we are bigger than some value and left is greater than... If we are greater than the threshold and bigger than the guy on the left and bigger than the guy on the right, we're 255. Hell yeah. So the question is, god damn it. Hold on. Someone's mad. Hold on. Because we're stubbing code out, people are mad about unused variables. Unbelievable. Okay. So those are... I think we can probably drop the threshold a little bit. That feels pretty noisy to me. We could also maybe, instead of like, how do I say this? We could maybe do like the hue detection on the gradient itself, right? Like you might be able to say like, instead of saying, hey, this pixel is an edge, I will count this as like a potential part of a line. We could maybe like weight it by how strong the line is. You know what I mean? That might be better. We might not have to do edge detection at all. Yeah, fuck that shit. Why would we need to do this, right? So if we have gradients, we can pick lines based off of like we can multiply by the strength of the gradient. And then we don't need to do this at all. Then we can kind of work off we can work off this image instead. Hold on. I lost it. Let's bring it back. Gradients. Gradients, this one. For Thrix. Thanks for the tier 1, much appreciated. Then we can work directly off this image, which I think might be pretty good. Right? We have some issues where, like, kind of like over here, it might not be, like, super fucking clear. That is a little concerning. In my brain, ooh, that's interesting. So, like, when I zoom out, I feel like I can see these line widths, but maybe when you zoom in, it starts getting a little hard. We might want to start with, like, an easier sample to deal with. But we'll see. We'll see. It'd be interesting to see... Because there are some, like, gradients here that we can see. We also might want to raise the resolution of this guy a little bit. And we'll see. Anon, thanks for the prime. Yeah, we'll see. We'll see. But I do like the idea of, like, fuck edge detection in general. Let's just work off the gradients. Surely that concept would work. Okay, so let's start by trying to, get some, like, consensus on, how do I say this? X direction of this thing. We've already done this a little bit. I want to see if we can maybe get, we did this before by just taking, like, averages of all gradients that lined up as, like, how we extracted this guy in the first place. But now it's kind of, like, maybe a little bit more complicated. I think that we might want to do, like, some sort of, like, peak finding or something. So can we... Do we even need that? Yes, because we want all of the lines to line up, right? We want to say, hey, we have a bunch of lines like this, and I want a histogram of all of their angles, right? So that we can have like kind of like angle will look like this, and we'll say like this is the angle, and then once we have the angle, then we can kind of encode this as offset from the side, right? So we'll say that all of these pixels, given this angle, agree on some like center location. Yeah. Yeah. Okay. So let's start by finding the bar rotation. Let's kind of agree on this shit. Okay. Okay. So that looks like maybe we build a little histogram first. Seems reasonable. We can look at that histogram. Horizontal line from center. Yeah, something like that. Like distance from left or from yeah. Horizontal line from center or left edge. I think are both fine answers. So angle histogram, I guess. Uh, is angle the right answer? Sure. We need some way to make a histogram, so angle retriever or something, which means that like somewhere we need data to go with that thing, so angle retriever is an angle retriever or something. I don't know, man. It would be nice if these guys just lived somewhere that was easy to pipe around. Can we just shove it in this structure? We might be able to. We might be able to. Angle retriever, angle retriever. And does this thing need to be like its own thing, or can we just have like a generic histogram retriever? Yeah, there's no reason that this type can't be reused. So we'll call this Y gradient retriever, and then just put like a, maybe we say hist retriever or something, and then we can kind of use this everywhere. Okay. Okay. And is this a pointer? I think is better here. I think we can default initialize this thing. He does need an allocator. That's fair. Hold on. So this is gonna be like reset at some frequency. So can we just do this? This is easier. We'll just say like angle. This guy, we just make this a render allocator. Boom, boom. This kind of comes out like this. And then a bunch of people complain, but that's okay. Actually, what does this guy want? Never mind. Wait, I've changed my mind. We need some allocator is equal to GUI alloc t make sub alloc angle or something, whatever. Doesn't matter. Does not matter right now. This is all bullshit that we don't need to think about. You know? Not really related to the problem we're trying to solve right this second. Okay! So now we just need to, like, populate this stuff with data. Let's make sure that, like, if we do that, we see something. So this should be, like, angle histogram. And can we kind of, just for now, do something like... update Update with new values. This is what this is supposed to be called. Update with vowels. Okay. And so can we just for now do like 10, 10, 10 or something and just kind of see what happens? I'm hoping that we see a histogram. Maybe we'll do like 5, 10, 5 or something. If everything's hooked up right, we should see a histogram that kind of goes like boop, 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 you know? Here we go. Nice. Nice. Okay. We got our histogram. Now, we want to fill this with, what are we looking for? For each point in the image, what do we think the angle is? So I think we like loop over all pixels in the barcode gradient. Yeah. So we go like, barcode gradient, iter. And we say, like, for each pixel in this thing, let's look at this thing. Right? And can we say, like, angle, I guess, is maybe we snap to the nearest degree? Maybe? Sure. So we have a tan 2 of, you know, the y over x of the gradient. This is gonna be, I think negative pi to pi. I think that's what this comes out to. And so here, if we want to convert this to degrees, it's like angle times 180 over pi, right? And then this needs to be plus 180 to get in the range of 0 to 360. And then we do, this is like as a U size, and we int from float here. I think that's right. We might need to clamp here, but that's fine. And then we just say, like, does this guy copy? He must copy the values, right? Yeah, he does. So we can just say, here, we have our, you know, histogram is 360 floats, right? And can we say, like, 0 times 360? Is that how this works? Does that compile? And then we can just say, like, hist at angle deg, it plus equals the magnitude. Yeah. So we take, like, the length of this vector. That seems right. That seems right. And then maybe we should see something kind of reasonable here. Maybe. I'm not, like, entirely sure that we won't see something reasonable here. I'm hoping that we see some sort of, like, consensus. Fuck. I guess 360 is in the range of 360. Or is out of bounds from 360. So can we do, like this? Percent 360. I think you do splat 0 to enter the array. Oh, good call, good call. Okay. So, good news. We are actually seeing dual peak. It looks like 3 peaks, right? But, we have to remember that the gradients, like, go in opposite directions, right? Like, some of them are going right and some of them are going left. So, that's actually kind of reasonable. So I guess we actually want to do 180 here. And then hopefully we see single peak. Yeah, and then we have single peak, but it's kind of like, you know, on the edge here. And that, so in reality, what do we do here? Like, we don't have to work in this space, I don't think. Hold on. Okay, so if we wanted to do some sort of like peak finding here, you would. So averaging here is easy, right? With averaging, you can kind of just go like, let me take the X and Y direction of these guys. This is what we've done in the past. Is we just go like, okay, this guy points this guy way, this guy points this way, this guy points this way, this guy points this way. Let's just like take the average of those, right? If we wanted to do something more intelligent here, like find the dominant one instead of the, how do I say this? Dominant instead of average, right? Where you want to like be like, I want to like look at these guys more. Is there a way to work with this so that you don't deal with this like wrapping problem on the edge? I think you just wrap around when you're doing your peak finding, right? So here we have like something that looks like this. And then you can kind of like wrap left and right when you're looking for the peaks. But in reality, we know we can simplify this problem because we know that our peaks are like the answer should be approximately equal to 0. Right? We want an answer close to 0 because this thing is supposed to be fucking horizontal. Right? So we can just simplify this problem by not worrying about it and phase shifting, like you said. I think. Fine, we'll go plus instead of minus so we don't underflow. Oh, oops. I'm a dumbass. Plus 90 here. There we go. That's pretty nice. That's pretty nice. And then maybe we do a little bit of smoothing at this and then pick the peak. Seems kind of reasonable. Right? So just like, you know, 4, you know, 0, like, 0 to 180. I guess this should be 180 here. Calculate the centroid, x times fx. I don't know what that means. Angle times the angle occurred. Angle times the number of times the angle occurred. Why? Angle times. Yeah, I don't think I understand why you would do that. Because what doesn't that just mean like as you get bigger, like doesn't that weight like as you, like farther over here, like the value gets weighted higher? I must be missing something. I'm just gonna do this instead because this makes sense to me. So I'm gonna say like, you know, I guess probably like 1, maybe 2 to 178 or something, right? We like do, you know, 4 I minus 2 to I plus 2, whatever, and we just like average all these guys. So we say like, I guess we'll call this hist 2, like this. So we'll say hist 2 equals, I guess we like do like sum here. Then we do like sum plus equals hist at j hist2 is equal to the sum. And we don't have to actually divide because we're just looking for peak. Right? Sure. Seems reasonable. Let's take a little peekies. So does that look like a little bit more sane? Yeah, that's like a little bit of a nicer thing. Right, that's like a lot less like noisy, and we just pick the biggest. So instead of like actually sticking this somewhere, well, I think we'll figure out splitting out like visualization stuff from everything else later. But it's fine. So we have like angle max here is f3 u size. Yep. Then here we say or I guess this is like best angle. We have best angle val. This is f32. We say if sum is greater than best angle val, we say best angle is equal to I and best angle val is equal to sum. Okay. These things to be variable. True. So true right now. Yep. And so then we have like we need to like write down like phase here. Let me think. Phase is 90. Here, phase offs degrees or something. Right? Because then we have to undo it here, right? Equals. So we can't just subtract 90 because we modded 180 here, so this thing might end up being like near 0. No. He might be a little lower than 90 though. A little bit, right? It might be like here or something. Or I guess it's like, you know, this is 90 and this is like 85 or something. And so we can't just subtract here. Why not? So what are we supposed to fucking do here? If it's 85, what's the actual answer? It's like a little bit 85 in our world is like -5, I guess. Yeah. So this is actually like output angle degrees is something. I guess it's like an I-32 is equal to best angle. Yeah. And then we can do output angle degrees minus equals phase offset. Nice. And then we can do output angle day, like mod by 360. Or we can just leave it like this. Yeah. Sure. Surely there's a better way to do this, right? Like, this is like losing so much precision. So, probably what we're actually supposed to do is like turn this into a curve that we can find the peak of or something, right? But whatever. Angle is this. In reality, maybe we should be allowing kind of Yeah, it just says angle 8, right? Which is like, sure, this says 98. I mean, true. Um, yeah. In reality, we should pick like resolution here, right? So instead of converting to degrees, we should be like converting to like his res. And everywhere we see 180 here, we just say like his res. Uh-huh. And then phase offset should actually be like hist res over 2. Okay. Okay. Hold on. We're getting somewhere. Uh. Okay. Phase offs here. And then this is now in units of hist res. Uh. So can we do this in radians or something? Or like times 180 over hist res? That seems kind of reasonable. You know, something like this? And then actually, can we do this as float? Yeah, that seems like it might work. Okay, so right now we should be getting like 8, right? That's hype. He says 8 there still. But if I like crank up the resolution now, you know, to like, you know, I don't know, 500 or something. .92. So he's drifting like a little bit left on this guy. Yeah, because here we're like, I don't know, at position 272 here, you can see the buckets are smaller. And maybe like the averaging should get a little bit larger too or something. But probably there's like, you know, probably better mathematical way to derive this, smile. But fuck it for now, you know? And then like here we probably want to pick like smooth sides as well, right? If we want to grow this. Right? Just kind of like whoop, whoop, whoop. Right? If we wanted to up this to like hist res over, you know, 100 or something, right? Maybe we could do something like that. Maybe. Right, so now the peak is like a little smoother. And we got an angle of 7.92. Okay, cool. So let's say that's fine, right? Is that the right answer? Hard to know, right? The fact that we have this dual peak is like a little bit of a problem in and of itself, right? It means that some of these gradients are like less sure. So probably taking the one that win, like the maximum is probably the better one, right? Probably. Maybe. It's probably, yeah, probably. Sure. Um, right. We have to remember that gradients are downwards, right? Because increased pixel is down on the screen. So this 7.92 is rotated down, not up, like you would think. But sure. Okay. That seems fair. So that's an angle. And now can we build a histogram of edge positions? What do these angles mean? I wasn't here the other day. We left for a couple minutes. It's like, given this picture, how do we think that the barcode is tilted? We're using this so that we can basically say for each pixel position here, we can calculate what its offset would, what its horizontal offset would be on the center line, right? So if you're like trying to say like, yo, I have a line like this pixel right here, what is like one number that can represent that? And we want to use this where this line would intersect with the center line, so that we can kind of say, as we gain consensus over all of these points, all of these guys should agree that we're kind of around here. And so the angle is important because we're gonna have to do like this, right? We're gonna have to go like, okay, so this is like this far down and this far to the left. You know what I mean? You know what I mean? Something like that. So let's try to build that idea now. Let's try to build that idea. So we are at 40, 55. Holy shit, time flies. And let's try to calculate that. So we can kind of do another walk over this thing where we're gonna build like another histogram. And this guy's gonna look quite a bit different. When you draw a line across when you draw a line across the center horizontal, you get the angle. Other way. So we have like this picture. We have this picture where we've kind of said, given each of these, every pixel, look around you and see how much you change relative to the pixels around you, right? So if you have like a line like this, and you're trying to see like the transition from black to white, like at this pixel position, the arrow is going to kind of point like away from this, hand wavy. And so we're trying to say like, given a bunch of bars, let's get consensus on like this arrow. That's kind of what we're trying to grab here. And then we're going to use that arrow to figure out how offset he is from the line that would go through the center. I think. I don't know. It's pretty hazy in my brain too. Do you need to know the angle to check consensus? So my understanding of the normal Hough transform is that you have like a line somewhere, right? And they say like this line is maybe offset from the center of the image, right? Boom. And so for each point here, you would pick, hey, how far am I from the center if this like perpendicular line went away? Boom. And then from there, you can gain consensus between each of the pixels on like all of these guys say like, I think I'm part of a line that has this angle and this distance from the center. I meant consensus for the barcode value. I think that what I want to do here is parse the barcode based off of the results of this next histogram, right? So what I'm thinking that we're going to get is, now that we have an angle, we can like start building consensus for each of these lines, right? And so I'm thinking that if we have like all of these distances, we can kind of do the barcode parsing off of that, if that makes sense. Which maybe wasn't very well explained. Might not have been. So I'm trying to like basically get the distances between lines through this transform, and then the rest should be easy, I think. Maybe. Okay. So yeah, what I'm hoping to see is some histogram that looks kind of like this, right? Where like each of these is like the start and end of a section of the barcode. You know, like this would be kind of like whoop, doot, 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 you know, something like this. Something like this. Okay. So I guess we iterate over the image again. And here our output is going to be pixels, I guess. So we're gonna have like floating point numbers because we're working off the gradient. And how many of them? I guess like the width of this thing. Okay. And as we iterate pixel by pixel through this thing, we try, this is like the like X line, like consensus hist or something. So here we're gonna be like, I guess we need like the center. It might be easier to calculate, it's gonna be easier if we do this based off of like top left pixel probably, right? So like this is, you know, y 100, this is x 100, and our angles are like this. This is positive. But then I guess if we have like an angle that drifts like this, I gotta, not sure. Brain's not quite working. Okay, it's fine, it's fine. Let's say center. Let's say center. Center Y is calcite. Okay, so for each pixel in this thing, we're gonna like look at his X position. And we need to like figure out how that relates here. So, okay. This is our center line. This is our angle. So if we're like here, we are offset by in X by this much. Which is, we have angle and we have this. So if we're trying to find this guy from that, is that easy? Hold on. Yeah, this is unknown. We have y and angle. There's like some projection here, right? But we don't know this length either. This is the only thing we have. So it's just, you just have to do tangent, I think. So like, tan theta is equal to y over x. So we don't have x yet, so we do x equals y over tan theta. Yes. Cool. This should be in radians. And so we have like x offs is, okay, so we have like center y offs is an F32, which is ity minus center y. Now this stuff I think is U31s. So can we do, this is an I32 is ity, nice, and then we can do y minus this. Then what do we say it was y over tan theta, which you can clearly read from this. This says tan theta, and you can tell that. So this is center y offs over tan of output angle rad, and this isn't going to change, so tan of the angle is tan output angle rad. Nice. How can you tell that? Well, because words on paper are not to read, they are to remember, okay? Never forget that. So when I write stuff down, it's like I just am using it as a little bit of a, as a little bit of a reminder. It's like the shape of that looks kind of like a word. uh, so this is my X offset from this thing. And is that right? So if Y is like negative here, then the offset's negative, sure. And then we got to be careful about like direction here. So if we are like this is positive angle, positive Y, which means positive angle, positive Y, which means that our X offset is negative if it's positive. So that means that we should subtract. Because then here, we're going to have negative Y, positive angle, use the same positive angle. So we're going to add here. X. So this is negative, and we want to go to positive. Yeah. So we say like if Y is Y down is positive, angle down is positive, which means that like Y over tan theta is positive if we are on the right. So add negative, add a negative to flip. And then we can do X, center line intersection. X point is X plus X offs. Nice. Cool. Cool. And so then we look into our X consensus histogram. And we try to, like, X pixel, center line X pix is, I guess, a U size here, which is going to be like a math clamp, probably, of something. 0 to however many pixels. Right? Well, probably we just want to discard if it's out of range. So yeah, because it can't, like, this should never be relevant. So like if center, like assuming center should be like has the barcode in it, lines that go through center -1, like less than 0, or center greater than width, by definition are not part of the barcode. So we just discard those. Yes. Or center line intersection let is greater than the X consensus his len. We continue. That seems right. So now all we have to do is be like, take his index here, which can just be int from float now, probably around here of the center line intersection X. And this guy, we add the like magnitude of the gradient at this location, the X magnitude probably. Yeah, sure. Yeah. That seems nice to me. This needs float from int here. This guy needs So this is float probably. Okay. Oh my god. Let's do this. Oh no, we can't do that yet because that was the whole point of this guard. Okay. Gross. We'll fix this later. Okay, do we have a way to visualize this thing? I would love to do that. So, image views, like X consensus, update with vals of X consensus hist, and then we just have to make that thing. Okay. Okay. And then somewhere we need to like X consensus here. And we use X consensus here. Everyone's happy. No field, X consensus. X, whatever the fuck I called it. And we should mem set this thing to 0. I forgot. Fuck. 512 is out of range 512. Yeah, this should have a greater than or equal to in here, huh? Not just greater. Don't you miss your C casting? Well, C casting has its whole own set of problems. Am I fucking stupid? Oh. Rounded is, we do the round first here. Because he's gonna get pissed. Whoopies! Okay, so how we looking? X consensus. Oh, we need absolute values here, I think. Because we're looking for magnitude, not like direction yet. Later we'll look for direction, I think. Maybe? So this is interesting. This is not at all what I expected. So this means that we're getting to like... Yeah, why is it growing? Right, like, I can kind of understand, like, this idea. This is kind of what I was looking for, I think. That we have, like, you know, 166, and then 173, and then 180, and then 188, right? That makes sense. I don't understand why it's getting so big towards the right. That seems confusing to me. So, it could be a bug here. Definitely. Let's start by not doing this X offset shit. So this is should just give us the X pixel position should just get the magnitude of the gradient in X at this location. See, this is much more sane, right? Here we're seeing like somewhat of an even spread, right? That like matches kind of the X position of where we'd expect this stuff, right? Consensus, more like. Yeah, true, right? So like we should be seeing like two big lines on the edges ish, right here and here, and then we're seeing like, note that like taller peaks don't necessarily mean like better consensus, because we need to do some smoothing here probably, right? um but yeah, that's kind of more what I would expect, which means that this math must be wrong. So what are our options here? Angle is this. What is this in degrees? Let's just double check that that's right. So we're expecting something like a little under 8 degrees. So this times 180 over 3.1415962 or whatever. Yeah, okay, so that thing seems kind of right to me, which means that tangent of this thing should be right. Now, I don't know if I actually didn't check that the tan built-in is doing what I think it does, but we should check. Zig built-ins. Build tins. Zig lang ref. Assuming that does what I want, but it's worth checking. Tangent trigonomic function on a floating point number in radians. Sure. So that's reasonable. We can check the value of this. So that's makes sense, right? So near 0, I guess. Yeah. So if y was like completely vertical, this should be 0. So I think that makes sense, because it's like we're moving a very small amount of x per y. Think that makes sense. So then we're saying like take. Whoa, hold on. I think this is back. Tan theta is y over x. We have y, so we have to get x. But I think that this angle is wrong, right? So this angle is very shallow. I think it's actually this angle. I think we have this flipped, right? Because if this thing was vertical, this is when like y movement, any y is like 0x, which is 90 degrees off of like, that is true if this image is perfectly horizontal. So this is backwards. This is backwards, which is fine, right? So we can just say you know, tan theta is equal to y over x, but note that theta grows. Note that our theta is that as our angle approaches 0, the x offset for any given y approaches 0. So we actually want the other angle in the 90-degree triangle, which results in xy flip. Sure. That's kind of like a fucked up way of thinking about it probably, but fuck it. Okay, let's try that. That probably explains why it looked so fucked up. Okay. So we're hoping to see like sharper lines here. Which like maybe we're seeing. It's hard for me to like imagine what this is, you know? I don't really know like what is the like size of this image. It's 512 pixels wide. So how many peaks are we expecting to see here? Like what is like 5? Oh, what am I doing? That's not a calculator. 512 or 96. Every like 5 pixels or something is like what we're expecting to see. Maybe a little less, right? Because this kind of like not fully like it's not taking up the full width, right? So maybe like every like 4 pixels even. So like here we see a peak here, 100, 1, 2, 3, 4. Here's 106. There's a peak here, so that's like maybe fine. Then here's like 112, another 6. Then like 321. Interesting. I suspect we want to do some smoothing to this. It's also possible that working directly on the gradients is not the right call here. Maybe. Maybe it would be interesting to render this as like an image. You know what I mean? Like show these values as like pixel intensities almost. And then hopefully we would see high intensity values line up with centers of lines ish. Yeah, let's do that. Let's take the gradient image here and on top of it um render like vertical lines or something. Um yeah. Oh, you know what? We forgot to do. Hold on. Maybe this is right. Could be, could be, could be. Okay. Yeah, because absolute valuing the gradient here, I think is probably right. Sure. I mean, maybe also like arguably x gradient is wrong, but should be like how aligned we are uh with angle, right? Like it pixel dot um you know something. But like since the angle is supposed to be low, it's like effectively the same thing. Hand wavy, so maybe it's fine. But like angle is expected to be small, so x is approximately equal. Okay, let's try to draw a picture here. It'll be easier to draw this on blurry. So let's do that. Uh, um, maybe not. Because doing it in grayscale means that like the lines that we draw aren't going to be very useful. Can we do an RGBA? And then X consensus image. Did I spell it wrong here? Consensus. Wait, what's he pissed about? Consensus. Consensus. Oh, image and image. I see. I see. Okay. So let's figure out how to make this thing. So we say like make some like init RGB image. No, because when we turn this into a texture, do we have an example of just like, we have gradient to texture? Who uses this thing GL pixel? That's what I'm looking for. That's what I'm looking for. Okay, so make an image of GL pixels. Initialized with our allocator. And width is like this. From the barcode, from like the edge image or the gradient image. And I guess it's actually, can we do this actually? Gradient to image to RGBA. Yes. And so can we export this guy as an image GL pixel here? And he's going to take in just like alloc of studmem allocator. Huge. We do all of the stuff we were doing in here before. And then we just return out here. And then this guy can call gradient to RGBA with the scratch allocator here, because he's going to immediately nuke that shit. Okay. And now we can call that and throw some extra shit on top of it if we want, right? So we can say like gradient to RGBA given our scratch allocator, and we are copying, what is it, gradient? Barcode gradient? Nice, okay. Sure, whatever. X consensus is equal to this. Okay, then we can go over for each consensus histogram, like draw in like blue over top or something, because blue isn't used. And I guess we want like the maximum here as well. Consensus max. If val is greater than consensus max equals val. Okay, and then we go again. And we say like, I guess now it's like for our image iterator. We say like for each pixel in this thing. We like yoink it from the histogram. Yes. So the blue value of this is the intensity of the histogram. Yeah, that sounds right. So like, so this is like at the X position, right? And this needs to be divided by the consensus max. Okay. That seems pretty good so far. What's it pissed about? Times 255. Of course. Because 8-bit image. And then this is all float, I think. Sure. So then we just have to like do update X consensus image with X consensus image. Okay, and then we just need to like make that thing. Okay. Update X consensus image. So this is going to come from a thing of GL pixel. And so that means that we need like make texture from RGBA with the data pointer cast, probably. I think that makes sense. And then the rest just kind of works itself out. And then this thing needs to be shown in the UI. So here we say we get the histogram. We also get X consensus image. Okay, that like might work. So here's our histogram, and then here's our fucking. Where's our fucking image? Okay. Gradient to texture. How do they do it? Yeah, it's just this. Can we start by just copying in the gradient? Like, what have I done wrong here? Like, fuck all this stuff for a second? Like, should this not give me what I want? Like, we display that thing here. We should just be mirroring that down here. Why the fuck aren't we? What am I doing wrong? So gradient to texture calls gradient to RGBA, make texture from RGBA. Okay. Gradient to RGBA, make texture from RGBA. And then... Oh, this is just the wrong fucking picture. That would do it. You do need to edit the variable you're trying to edit. Hot take. Okay, he's back, and then let's add the blue lines back now. All right, so what we're hoping to see is blue lines that go through centers of the red lines. Vertical blue lines that go through centers of red lines. Bad news bears. Kind of. Right? Like, there's definitely something interesting happening here. Right? Like, you can see here, you've got, like, a pattern here. Like, we're definitely seeing something. But it's not quite what we're looking for. But it's not super far from what we're looking for either. I think we might just want to do, like, edge collapsing from the canny edge detector again, right? Where we, like, smooth and take peaks? Yeah, I'd be interested to know if we can make like amplify the peaks. I think I've seen something called kernel density estimation before. This I remember seeing a picture like this. This is kind of what I'm looking for, right? Something where we can like kind of like make peaks stronger. I don't know if that's what this does. Sorry, I'm just thinking. You could like Okay, what am I really trying to accomplish here? We're trying to find peaks in this thing? But we want to make sure that there's not too much noise here, right? Because, like, slight offsets in any line here, right? We're going to have, like, a gradient speckled like this, right? Why is that fucking moving? And, like, you know, over time, this kind of is going to, like, look kind of like this, right? And hopefully, like, you know, most strong pixels kind of, like, line up towards the same center line here. And I assume, like, fatness of lines here is kind of indicating, like, Like, I'm worried about, like this kind of shit here, right? I'm worried that these peaks are like, how do I say this? Like, kind of, I worry that we're like, we don't have enough information or something, and that if we did like just like simple smoothing, they would get lost. I guess what I'm like a little confused about is like, why is there this like high flat area? Right? What's causing that? Because like, really, what I would expect is in a barcode, you should be having like, an ideal signal is like this, right? You have like white, black, white, black, white, black, right? And in that ideal signal, with these like really sharp corners, your gradient should be like high, uh, like high, low, high, low, high, low, high, low, right? That's kind of what I would like hope to see. Now, what we're seeing, if I understand this correctly, is like high, medium, gradient, high again. And it's like, what the fuck is this? Right? That's what I'm confused about. Interestingly, it's like kind of towards the center of the image, which is kind of in like this area. So I guess it could be that like this is kind of just blurrier. And so like the gradient is less sharp and is getting like kind of spread out a little bit more. Which would indicate that the idea of doing this on the gradients is not very good. Or we should like threshold the strength of the gradient or something. Only do it on segments where the gradient is over some value. We could try that. I'd be interested to know if that does something a little bit more interesting. To just kind of like stop some of the like bullshit. We could also try doing it on the edge data. That's also like another option. We could try doing edge detect and then do it there. But I'd be interested to know like okay, what am I looking here? So we have here. If IT pixel 0 is less than this, fuck off. Maybe that would make it a little bit more... Oh, that's way better. Right, you can look at this. That's way, like, stronger signal, it looks like. Okay. And then can we I want to make like strong lines here, so we can do kind of something similar to the edge detection stuff before, where we look to the pixel to the left and the right and say like fuck off if it's not larger. Okay. So if yeah, okay. So if us is, I think we've already done the thresholding. So if we're greater than left and we're greater than right, then we do this. So we're just gonna try like to take like the some narrow slivers now, which just seem to not exist. What? Surely these must exist sometimes. Let's try this. Oh, wait, hold on. Are we sampling from the wrong image? Yes. We're looking for, looking at this X consensus histogram here. Yes. Aha. Okay. Oopsies. Bring this index here. Okay, so we look to the left, we look to our right, and us is X consensus hist at ITX. Okay. Let's try that. Still nothing. What the fuck? Am I fucking stupid? Am I fucking stupid? What am I missing? 0, 0, 0. Hello? Zero, zero, zero. What then? What were we looking at before? Am I fucking crazy? Like, we're seeing, clearly that's not true. Clearly it's not true because we have fucking blue. Like, it's in, like, oopsies. Right? So, like, the fuck? I guess sometimes it's 0? Oh, I was using the wrong fucking iterator. That would do it. This is why you fucking split functions. Too much scope in one fucking function just like ruins my brain, dude. There's just like too many things to make mistakes on. Okay. So, one. Not looking as good as I wanted. Not looking as good as I wanted. I really thought that this would do it, dude. Can we do this? X consensus hist times, what was it? It was like max or over consensus max times 255. Filter some stuff out. Okay, wait. Yeah, so some of these lines are quite strong, and some of them seem to not be, right? Like, here we're seeing like a very faint line on this, then a faint line on this. Oh, you know what it is? I bet you it's that the using I bet you it's the fact that the thing is fucking warped. Is it? So like here on this guy, here he's lining up with like 1, 2, like a few pixels to the right on the bottom. Okay, maybe let's start like here. So this guy, he's lined up with the bottom there and like a little bit to the left of the top there, right? So it's like good. But this guy, look at this, look at this. From here, from the bottom all the way up to the top, look how far he is from that same line. He's moved like a bar and a half over, right? So it could be, you know, when we look at this guy, how they have like different different peaks here. It's almost like we need to be respecting the angles of the individual lines. That's pretty interesting. That's pretty interesting. Yeah, so we can't, I guess this means that we can't use the same angle for every line. I guess that's what this means. Which makes sense. I would like to try this on like a more stable image. So I'd like to know, you know, like this guy's pretty flat. Like, do these lines look more crisp here? And maybe showing this on top of the original image as well is gonna help us. Because like on the gradient image, I feel like it might be a little bit difficult. So can we do this? Grayscale to RGBA. Like this. So now we can go, start with grayscale to RGBA with, barcode start is the name that we were using for this guy. All right. So overlaid on the initial. Why are some of these lines yellow? Hello? Oh, because we need to set, oh, maybe that was also confusing stuff. We need to set R and G to 0. That might have been making this harder to, like, visually parse. Because we were, like, leaving in, you know, white pixels as white or something. Okay. So the question is are we getting good edges here? And the answer is no, right? We're only getting right side pixels. We're only getting, whoa, that's a bug. We're only getting dark to light pixels here. Right? We're not getting any light to darks, which means that like somewhere we are not absolute valuing something that we're supposed to. It has to be, right? Abs here. Okay, try again. Okay. So that's looking pretty good in a lot of this. We're missing the left edge on this guy, but otherwise that looks good, that looks good, that looks good, that looks good. Bing, boom, 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 boom. All of this looking pretty good. I don't know what's going on here. This is concerning. I don't know what the fuck is going on here, but the rest, that's looking like pretty good in a lot of ways. What the fuck is this? Like, what, why is there just like some fucking black line here? This is new. Very strange. But yeah, that's kind of close. Can we just do 255 here raw again? Oh, that's probably what those black lines were, was that they were like low confidence lines, right? So I think there's like a little bit of a shadow down here. And so we probably need to add some like confidence threshold there. But other than that, is it good? Maybe this is right. No, we're missing this line here. We have to be. Yeah. Close, though. Close. The idea, I think, is kind of sound. So I think that the can I look at? I want to look at this with the other visualization. So instead of strong lines, this is why. I guess without thresholding was when it looked like really blue and blurry before. That's still really sharp. Why is it so sharp? I feel like before it looked like really blurred blue. How do we change that? It was like whatever we did to make this histogram look less pointy. I feel like... Oh, it was this. It was this. Where we filtered by only showing the ones where we're really, really fucking strong. Show me fucking everything. Show me the world. Oh. And then, leave the underlying image. I think it's max here. So that we're not like, I want to show like the blue line on top, not like not like delete the blue from the original image, which means that we have to do something here, right? Like old blue is new like consensus amount or something is like this, and then we do like this is a U8. Then here we can go like maximum of the old value and consensus amount. Yeah. Oh, and then comment this out. Jeez, it's so hard. So hard. But now, there we go. A little bit more like soft bluey. Yeah, this is pretty interesting. So like whatever the fuck is happening here, can we like boost the blue a little bit so we can see more? Can we boost it so we go like I guess it's like you know, something like this. But like, can you do saturating multiply? Is that like a thing that exists in Zig? Yeah, you do. Nice. So you can do like saturating multiply. Nice. By 4. And then you should get kind of big, like, we should see more blue everywhere. Okay. Yeah, it does kind of look to me like in this area, it's not getting like a constant signal. Which kind of, I guess, lines up with this, where we're kind of seeing like two peaks. Is that the right thing here? We should probably this image view, we need to like show what pixel we're hovering. Like that would just make all of this way easier, right? It's hard to like correlate this thing with this thing. I guess we can stretch this to fill the width of the screen, and then the histogram should match this perfectly, I think. Root GUI here. So if we just say, fill width on this thing, on these guys, I think that that'll make them line up with the images better. I think. We'll see. Yeah, I think so. So like this is this peak. Then we have like a smaller peak here and then a big peak here. Yeah, so like it lines up here where we don't have like 4 strong peaks on this edge, which sucks. But this could be again because like the angle. Can we try? Are we working on like the blurry image? What's going on here? Are we update image views? Right, we have blurry here. Can we generate the gradients off the blurry image for a second? I just want to see if that changes anything. Let's do a little bit of vertical blurring. It definitely makes like this histogram look. Oh, I don't remember if this. I actually don't remember if this histogram looked like that before. Yeah, that might help. It might. Let's bring this back. 'Cause I'm just a teenage dirtbag. Alright, let's try this. Give me some strong blue lines real quick. I think that might be pretty good. Right, so we got like 2 lines here. So this... dark, white, dark, light, 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 dark. Yeah? I mean, there's definitely some like double lines going on here, I think. But that's like correct, which is pretty sick. It's weird to me how biased it is towards the top. I guess like if you look at this, like it's pretty fucking warped actually. Right? Like you can kind of tell that like everyone on the bottom is kind of curving in towards the middle, which is kind of fucked up. So it might be that the answer here might be to like do like a center crop or something, right? To kind of like prevent the magnitude of this warping. Can we go back to the fucking mayonnaise bottle? Yeah, I mean, this is pretty rough. Pretty rough. All right. I mean, there's definitely like some legs to this idea. It's definitely not as much of like a slam dunk as I thought it was gonna be. So I think I'm gonna have to think about it a little more, play around some more, right? As usual, we try something, we find its problems, maybe it's not as good as we thought, right? It's part of the process. So I'm gonna think about this. Call it there for today because I'm really not sure where I want to go next. But I think this is, what's that thing that they say? Negative results are still valid and useful results, right? So to make ourselves feel a little better about this thing not going as we expected, as we wanted, it's okay. It gets us closer to the right answer. It's gonna be funny when we end up just like doing like one scan line against the bottom. But we'll see. So call it there. Thanks for watching, guys. If you like what we saw, we stream most days from 12:30 Pacific time to 4 o'clock Pacific time. Today, we were doing, it's a little shorter because I just felt like it today. But yeah, some amount of the stuff goes onto the YouTube, some does not. Basically the metric there is just like, if I think that it's something that's like clickable, something that the YouTube algorithm will promote, well, it goes on the YouTube, but everything else goes on Patreon or Twitch VODs or YouTube members. We do that so that like if you want to support to make sure that the stream stays alive, because when I run out of money, I'm gonna have to stop streaming, get a job. We have something to give those people. So please consider supporting, but obviously no pressure. Yeah. YouTube, peace out, and Twitch, let's find someone to raid.